All right, hello. We're going to go ahead and get started as it is 10 a.m. and we've got a lot to go through. I think people might trickle in as we go, but as always, these will be recorded and available for you to watch at a later time. My name is Maxine Horn. I'm a learning specialist at the Academic Support Center. This is the statistics test 3 review. This is on chapters 4 and 5. And we're just going to go through a bunch of practice problems. These are on the review homework for chapters 4 and 5. This is my card with my information. You can also, if you just type in Maxine for an email, you can reach me there rather than typing in my first name. I know it's confusing. I go by my middle name. But all right, let's go ahead and get started. So here we go. All right. Hi, Cecilia. Welcome. So we're going to jump right in. Number 1, state whether the variable is discrete or continuous. And it gives the example of the cost of a statistics textbook. So this is discrete because it is finite. It is countable, right? So the cost, that's a dollar amount, right? That goes to 2 decimal places. So that's going to be a specific countable number, okay? As opposed to the next one, which is the blood pressures of a group of students the day before their final exam. So this is continuous because this can be, it can take on any value within a given range. So we're only limited by the precision of the measuring instrument, right? So it can be a whole bunch of decimal places. It can be, you know, any number within, any value within a given range. So that's what makes this continuous. All right, so the random variable x represents the number of credit cards that adults have along with the corresponding probabilities. Find the mean and standard deviation. Okay, so when you do these, you're going to be in your calculator. You're going to put them into, here, let's label these. This is going to be list 1. This is going to be list 2. So this is similar to some of the things we've done before, right? So we're going to go to stat, we're going to go to edit, and we're going to put these in list 1 and 2. And oh, I already have this in here. Okay, so once it's in list 1 and 2, then you're going to go back to stat, right? Stat, and we're going to calculate and 1 var stats. Make sure that you have list 1 and then list 2, and then calculate. So we can see here that the mean is 1.23 and the standard deviation in the calculator it's showing is that, right? This one right there. That's the 0.66. Okay. All right. Use the probability distribution to complete parts A through E. All right, the probability distribution of the number of overtime hours worked in 1 week per employee. So when we do these, they're asking for a variety of things here, right? So the first one, find the probability of randomly selecting an employee whose overtime is 1 or 2 hours. So we're looking at 1 hour or 2 hours. So you can kind of think of this as, scooch this a little bit here. The probability of 1 hour plus the probability of 2 hours. If they overlapped at all, we would subtract where they overlapped, but this type of problem, there is not going to be an overlap, right? So it's just giving us those numbers, right? It's telling us what the probability is when that they would work 1 hour of overtime. So they said that that was 0.058, and the probability that they would work 2 hours of overtime is 0.127. So we're going to add those together, 0.058 plus 0.127, and that's how we're getting 0.185. Okay. Right, find the probability of randomly selecting an employee whose overtime is 2 hours or less. Okay, so 2 hours or less, 0, 1, 2, 3, 4, 5, 6. 2 hours or less means we want all three of these, right? 2 hours or things that are less than 2 hours. Right? So the first part is making sure that you're translating what exactly they're asking for correctly. Then the next step is figuring out what's the fastest way to find that. So here I can add three things up and I'll get my answer. If I wanted to, we'll do that in the next one, never mind. So we have the probability of 0 plus the probability of 1 plus the probability of 2. Okay, probability of 0, 0.026. Probability of 1, 0.058. Probability of 2, 0.127. And we're going to add those all up. And that's how we're getting the 0.211. Okay, find the probability of randomly selecting an employee whose overtime is from 3 to 6 hours inclusive. Okay, from 3 to 6 inclusive. So there's two ways to do this. We can either do the probability of 3 hours plus the probability of 4 hours plus the probability of 5 hours plus the probability of 6 hours. But instead of adding four numbers together, we could instead add three numbers together and subtract them from one. Because remember that all of the probabilities together add up to 1, right? The sum of the probabilities is equal to 1. So all of these together are 1. So if I'm trying to find this group, I can find this group and subtract that number from 1. And conveniently, what did they have us do in the question before? They had us find this group. So we can just do 1 minus the answer that we got in the previous problem. So we're going to do 1 minus, and then you can either type that in, or in case you didn't know, on your calculator, this little thing that says answer above the negative will input what you had as the answer. So you hit second and then the negative, and it will do answer, and it'll do 1 minus the previous thing you had. So that can be useful if you have like really long decimals, or if you don't want to round as you're computing. But that's how we're getting the 0.789. We would also get the same thing if we really did add the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. But why do extra work if we don't have to? All right, find the probability of randomly selecting an employee whose overtime is from 1 to 3 hours inclusive. Okay, so 1 to 3 hours inclusive. So that's these three right here. So we're going to find those probabilities and we're going to add them up. Okay, so the probability of 1 hour is 0.058. The probability of 2 hours of overtime is 0.127. And the probability of 3 hours of overtime is 0.307. It's a 3, not a 5. So we're going to plug those into our calculator. And we get 0.492. And last on this one, the probability of randomly selecting an employee whose overtime is at most 4 hours. Okay, so again, let's make sure we are interpreting what they're saying correctly. So at most 4 hours means everything up to and including 4 hours. Okay, so again, similar to this one, we can either add all these numbers together, or we can just add these numbers together and subtract them from 1, right? So that's what we're going to do. We're going to do 1 minus the probability of 5 hours plus the probability of 6 hours. So the probability of 5 hours is, you can't see that, 0.18. And the probability of 6 hours is 0.09. We're going to do 1 minus that, gets us the 0.73. Okay. Oh, just get the chat open here. I apologize. I did not have that open here. Okay, gotcha. Thanks for the heads up, Cecilia. And you can always watch this later. I'll email everybody that attends the recording, and then also your instructors will have access to the recording if they want to provide that to you as well. Okay, number 5. So using the data given below, determine whether it would be unusual for a household to have no HD televisions. And then they give us the data there. So, okay, they're saying no HD television. So we have no televisions, 1, 2, or 3 per household. So no televisions is this right here. Okay, so there were 78 households, and the probability of that happening was 0.03. So remember that when we talk about unusual, we're looking at this 0.05, right? So if the probability is less than 0.05, then it is unusual. So we're talking like less than 5%, right? Or I'm sorry, 5% or less. So this is 3%. So yes, it would be unusual because the probability of having no, that's 0, HD televisions is less than 5%. So that's come up in a previous chapter, and now we're looking at it again. Okay. The probability that a house in an urban area will be burglarized is 5%. If 20 houses are randomly selected, what is the mean of the number of houses burglarized? Okay, so here we're going to use one of the formulas that we have to make sure that we know, which is that mean is n times p. Okay. So let's go ahead and make sure that we label everything correctly. Okay. So our n value is the number of houses that are randomly selected. That's n. P is specifically what will happen or what is being asked. So just be careful with this because sometimes P is a not good thing. Like for instance here, it will be burglarized. That is what P is. So it's 0.05 because it's 5%. And then also you want to get in the habit of being able to quickly identify if that's what your P is, what is your Q. So remember that the value of Q is 1 minus P. The value of P is 1 minus Q. Right now, for this problem, we don't actually need Q, but we need to make sure that we're able to calculate it, if we need to. All right, so for this, we're going to say the mean, right? That's the formula we're using. The mean is n times p. Okay, so we're just plugging that in. 20 times 0.05. That's how we get 1. So you always want to, when you have these word problems, make sure that you kind of understand what it is that you just found. 20 houses are randomly selected. What is the mean of the number of houses burglarized? 1 house being burglarized is the mean. Out of 20 houses, 1 house being burglarized is the mean. Okay. All right, number 7. According to government data, the probability that a woman between the ages of 25 and 29 was never married, right, that's what they're asking or finding, is 40%. In a random survey of 10 women in this age group, what is the mean and standard deviation of the number that never married? So again, the P is whatever it is that they are asking for, not necessarily a positive thing or a negative thing. So, okay, so let's start labeling things, right? So we have our N value is 10. Right? That's the 10 women in the group that were surveyed. Okay, your P value is 0.4, and our Q value is 0.6. I don't know why that decimal got crazy. All right. Okay. So we already talked about the formula for mean, right? That's n times p. So let's go ahead and plug those in. N times p. Uh, if you're writing this out and the decimals and the dot for the multiplication get kind of messy, feel free to put things in parentheses just to be sure that that things are clear. All right. Also, you can always double check yourself on the calculator, but feel free to do things like this in your head, right? When you're multiplying something by 10, you could just move the decimal over one place, right? So do it in your head, and then if you're unsure, check it in the calculator. All right, so that was the mean. And then we have to know our formula for the standard deviation. So that's going to be the square root of n times p times q. Make sure that the top of the square root goes all the way over the p and the q. Okay. So let's plug it in. We have a 10. I'm just going to put everything in parentheses, make it easier. P is 0.4 and Q is 0.6. Again, that needs to go all the way over. So square root 10 times 0.4 times 0.6. And that's how we're getting that 1.55. Okay. All right, number 8, in a recent survey, 63% of the community favored building a police substation in their neighborhood. If 14 citizens are chosen, find the probability that exactly 5 of them favor the building of the police substation. Round the answer to the nearest thousandths. Okay, so how do we know what to use here? It's this wording right here. We're trying to find the probability of exactly a certain number of things happening. So we're going to be using, whoops, I can spell, where's my eraser? Binom PDF in the calculator. Okay, so that's what we use when we're looking for an exact value. Okay, so when we go to look for this in the calculator, this is going to be under DISTR, distribution, right? So we're going to hit second and then the vars, because the one above that is distribution. So second vars. All right, and we are looking for binom PDF. Now there's two ways to get to it. You can go down, 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 and there it is as A. Okay, I could do it that way. Or I can hit the up arrow and go up to the top and it loops around down to the bottom. Okay, and it's fewer clicks. Okay, or if I know for a fact that it is selection A, as opposed to like selection 6 or 4 or whatever, then I can select A with the keys. So A is it's the yellow just above math. So I'm going to hit alpha and then math, just like I hit second and then vars to get distribution. I'm going to hit alpha math to get A. So alpha math, and it brought me to that menu. So just good things to know how to navigate around your calculator. All right, so some calculators are going to be set up like this, where it's telling you, hey, you need to tell me this information, and this information. Some calculators will not do that. They're just going to say binom PDF with an open parenthesis, and you have to know what numbers go in what order. Okay, so when you're doing this and you aren't prompted for what is supposed to be here, what needs to be here is NPX. Okay, so let's go ahead and label these, right? So N is your trials. P is the probability of the particular thing happening, right? So that's this number right here. Okay, and X is the exact value that you're looking for. Okay, so the trials, the N in this one is 14 because they said 14 citizens are chosen. Okay, the P is 0.63 because that's what they gave us there. And then the exact value, the x, is 5. I'm going to go through a lot of lead. Okay, so let's go ahead and plug that in. There are 14. The p is 0.63, and the exact value we're looking for is 5. And enter. And that's how we're getting 0.026. And just make sure that you're rounding correctly, right? Because this is 0.0258. But they're asking us to go to 3 decimal places. So 0.026. All right. Okay, number 9. Probability that a tennis set will go to a tiebreaker is 14%. What's probability that 2 of 3 sets will go to a tiebreaker? Will go to tiebreakers. Round the answer to the nearest thousandth. So this is going to be the same process because we're looking for exactly 2 of the 3 sets going to a tiebreaker. Okay. So let's go ahead and label our n, our p, and our x. So it said that 2 of 3 sets. That means there are 3 sets. That's our n. The p is the 14%, 0.14, and they want to know the probability that exactly 2 of the 3 sets will go to a tiebreaker. So that's a 2. So again, we're going to go second vars to get to the distribution menu. And then I'm going to go alpha math to get binom PDF. And I'm going to plug in the numbers. N is 3, P is 0.14, X is exactly 2. And then, like I was saying before, if you have a calculator that doesn't prompt you, it's just going to look like this. It's just going to start with the parenthesis, and then you have to plug in NPX, and you have to do them in that order. Okay, so that's how we're getting the 0.051. Okay, number 10, multi-section one here. Okay, so a survey asks 1,500 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? 52% of those surveyed, I'm just going to write that down real quick, right? 52%, probably going to need that at some point, of those surveyed said they are reducing the amount of vacation. 10 workers participating in the survey, probably going to need to know about that, are randomly selected. The random variable represents the number of workers who are reducing the amount of vacation. Decide whether the experiment is a binomial experiment. If it is, identify a success, specify the values of N, P, and Q, and list the possible values of the random variable X. All right, so this is on page, what is this? I think 201 of the textbook. So if you have the electronic version, oh gosh, is this going to let me? Yeah, there we go. Okay, so these are the requirements for a binomial experiment, right? It needs to have a fixed number of trials where each trial is independent of the other trials. Okay, there are only 2 possible outcomes of interest for each trial. Each outcome can be classified as a success or a failure. And the probability of a success is the same for each trial. And the random variable X counts the number of successful trials. So does that apply to this question? Yes, it does. So that means that yes, it is a binomial experiment. Okay, what is a success in this experiment? So again, you just have to make sure that you're reading the problem carefully. You know, they are reducing the amount of vacation. Or I'm sorry, here specifically it says the random variable represents the number of workers who are reducing the amount of vacation. Okay, so that's the success. Okay, the value of n. So n is the number that are being randomly selected from the survey, right? So be careful on that. So the survey is the entire 1,500, but we are looking at a subsection of that. We are looking at an n of 10. We are pulling 10 workers from the survey and randomly selecting them, okay? The number that you're randomly selecting from the full survey, that's your N. Okay, so just be a little careful with that. Okay, the value of P. So they gave us that 52% are reducing the amount of their vacation. So the wording there does match up with what we're actually supposed to be finding, are reducing the amount of vacation. That's not to say that they might not switch that around on you at some point, and maybe they tell you the percentage of people who are not reducing their vacation. You would have to then subtract that from 1 or 100% in order to get the p-value. Okay, so then the q value, remember that q is the complement, right? We subtract it from 1. That's how we're getting to 0.48. Okay. All right, now listing the possible values of the random variable x, we have an n value of, oops, can't see that, an n value of 10, right? We labeled it up there. They told us that we have 10 workers participating in the survey, in this random that we've randomly selected. So we can have any amount of those 10 being a success, right? So don't forget that that includes 0. You can have none of them be a quote unquote success. So when you're making this list, don't forget to include 0. But you can have 0 people saying that they're reducing the amount of vacation, or 1 person saying that, or 2 people saying that, or 3 people, all the way up to you could have all 10 people saying that. Okay. From there. Okay, well, that's all right. Okay. Number 11, 59% of US adults think that civil rights for Black Americans have improved during their lifetime. You randomly select, so first of all, 59%. You randomly select 8 US adults, find the probability that the number who think that civil rights for Black Americans have improved during their lifetime is A, exactly 3, and B, exactly 6. Okay, so what are we going to be using here? We are going to be using the binom PDF. So again, we pull our calculator out here. Let's go ahead and label the N, the P, and the X that we're using for each of these. Okay, so the N is going to be our 8. Let's go ahead and label both of these. So our N is 8, our P is 0.59, right? Because we had 8 people, and then they're telling us 59%. And then the X, the exact value for this one, exactly 3, that's our X. So we're going to go second vars, alpha math to get binom PDF, or you can scroll down through. So we have 8.59, exactly 3. That's how we're getting the 0.133. And then so for the second one, they want exactly 6 out of the 8. So N is 8, P is 0.59, but now instead of exactly 3, we want exactly 6. So same menu, binom PDF, N is 8, not changing, and P is 0.59, not changing, but the exact value we're looking for now is 6. And that's how we get 0.199 when we round to 3 decimal places. Okay, number 12. All right, find the area under the standard normal curve to the left of z equals 1.25. Okay, so there's several ways to do this. So first of all, let's remind ourselves how the z-scores work. So your mean is in the middle. Actually, I'll just write mean, that's fine. And then you can go a certain number this way or a certain number this way of z's, or of standard deviations. Okay, so if I go, let's say right here, I go 1 standard deviation, that's a z-score of 1, because the z-score corresponds to how many standard deviations you are away from the mean. If I go to the left of the mean, then I'm 1 standard deviation to the left of the mean. That's a z-score of -1, right? So don't forget that that's what the z-score actually represents, okay? All right, so there are a few ways to find this. Um, we're going to do it on the calculator for this one. We're going to use the chart in some of the other problems, but for this one, we're going to use the calculator. All right, so what is it that we're going to actually use here? We're going to use normal CDF. Okay, CDF is cumulative. Cumulative meaning the area to the left. So z equals 1.25. So let's draw this one. All right, if the mean is right in the middle, okay, a z-score of positive 1.25 is over here somewhere. Okay, z equals 1.25. They want us to find the area under the curve to the left of that. So they want us to find this area. Remember that the area under the entire curve is 1. Okay. All right, so we're going to do normal CDF. So we're going to do second vars. Okay, same menu that we've been in. And we're going to go down to number 2, or you can hit the number 2 and it will select number 2, normal CDF. All right, now again, if you have a calculator that prompts you for, hey, what goes in here, that's great. If you don't, then you need to know what goes in the parentheses. What needs to go in, the first number is your lower bound. The second number is your upper bound. The third number is your mean, and the fourth number is your standard deviation. When you're working with z-scores, you're going to be wanting to leave your mean as 0 and your standard deviation as 1. We're going to get into problems where we're going to use different things for those, but that's what we're using here. Okay, so let's talk about lower bound. So what do I mean by that? So I'm talking about the boundaries of the shaded area. So the lowest area down here, remember, this isn't ever actually hitting the x-axis. It's getting really, really close, but it's technically going on forever and ever in this direction and in this direction. So these values are going up to infinity over here and down to infinity over here, right? This is never actually touching this horizontal line. So the value that I use over here, I'd like to use negative infinity. Well, unfortunately, I can't plug that into a calculator. But what the calculator does is it says, hey, a lot of times you want to use a really, really low number way down here. So I went ahead and I defaulted to -1 E99. Right? So we can plug something like that in ourselves if it doesn't provide it for us. So if we were having to plug these in ourselves, our lower bound would be -1 times 10 to the 99th power. That's often the kind of default that they want you to use, or something like that. Use a really, 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 really big negative number. Okay. All right, our upper bound, that is our z-score here, right? That is our 1.25. Okay. All right, so lower bound, upper bound, and like I said before, we are leaving our mean as 0 and our standard deviation as 1 because we are dealing with z-scores here. Okay, so what it gives us is 0.8944 if we round. It's always a good idea when you're doing these, or doing any of these problems really, when you get your answer, stop and make sure that it actually makes sense, right? Does it make sense that if I'm over here to the right of the mean, so I've shaded in most of this, that I would get like 89%? Yeah, that makes sense. It looks about like I've shaded in 89%. I mean, there's a lot of wiggle room here, but if I had gotten something like 2%, that would have tipped me off to, hey, I may have plugged something in incorrectly here. Okay. Right, number 13, find the area under the standard normal curve to the right of z equals -1.25. Okay, so again, we've got our mean in the middle here. This is a negative 1.25. Z equals negative 1.25. So negative means we are to the left of the mean. And they want us to find the area to the right of that. So we're looking at this area. Now there's two ways to do this. One way is to go back to this problem that we just did and say, hey, wait a minute, that z-score looks kind of familiar. This was a positive 1.25. This is a negative 1.25. If we're looking at the area to the left, and here we're looking at the area to the right, it's the same area, right? It's the exact same area. It's just on the right side versus on the left side. So you'll notice the answer is exactly the same. Now, let's say you didn't notice that. That's okay. You could just still plug it into the calculator the way that we have been, right? So we're going to go second vars to get to the distribution, right? Because these are all distribution related problems. And we're going to go normal CDF, cumulative distribution. All right, now lower bound. Well, this time my lower bound, as I go from left to right, my lower boundary and my upper boundary, my lower boundary is this z-score right here, right? Left to right, lower bound, upper bound. Where do I start shading? Where do I stop shading? Okay, lower bound is negative 1.25. My upper bound, that's this infinity that we were talking about. Well, I can't type infinity, so instead, I'm going to write 1 times 10 to the 99th. Or you can write something, some just really, really big number. But you can't write something like 100. That's not enough. It's got to be really big. So my lower bound is negative 1.25. My upper bound is 1 times 10 to the 99th. And then again, because I'm dealing with z-scores here, I'm leaving my mean at 0 and leaving my standard deviation at 1. And sure enough, I get the exact same thing I got last time. All right. Okay, slightly different approach here. Find the area under the standard normal curve between z equals 1 and z equals 2. All right, we're going to do this two ways. Okay, one of the ways that we're going to do this is kind of similar to how we've done the last few. All right, so the mean is here. We have z equals 1, whoops, equals 1, and then we have a z equals 2, and they want us to find the area between the two of these. Okay, so what we can do is we can find the, well, really we can just plug it in. Let's do it this way first, like I said. All right, second vars, normal CDF. All right, what is my lower limit? My lower limit is this value right here, this z value, which is 1. My upper limit is 2. And again, these are just z values or z-scores. So we're leaving the mean as 0 and the standard deviation is 1. So again, if we were to plug this in, if we were to actually write this out here, it might be helpful. Normal CDF, lower bound is 1, upper bound is 2, mean is 0, standard deviation is 1. Okay, so we're getting 0.1359. Okay, sounds about right. So another way that you could do this is to remember I'm trying to make this big enough so that I can actually write it, the 68, 95, 99.7 rule, which says that if you have a standard normal distribution, if you go one standard deviation out, which would be z-scores of 1 and -1, that the area between those contains 68% of the area. If you go out one more standard deviation, which is an additional, so z-score of 1, z-score of 2, z-score of -1, z-score of -2, that contains 95% of the data. And if you go one more standard deviation out in each direction, so a z-score of 3 or -3, that contains 99.7% of the data. Okay, so this is a z of 1, this is a z-score of 2, and this is a z-score of 3, right? z negative 1, z negative 2, and z negative 3. Again, that means that we took the mean and we added 1 standard deviation to it. We took the mean and we added 2 standard deviations. We took the mean and we added 3 standard deviations, or we subtracted. And I'm not trying to point to here, I'm trying to point to down here. I just don't really have room. Minus 1 standard deviation. This is the mean minus 2 standard deviations, and this is the mean minus 3 standard deviations. Okay, all right, so now that we've set all that up, they're asking for the area between 1 and 2 standard deviations to the right of the mean. So what we can do is we can say, well, if I have this area and I subtract this area from it, right? So if I have all of this, here, let me do some colored pens here. That might make this a little easier. So if I have all of this, and then I subtract all of this, I'm going to be left with this and this. Okay. If I take that and just cut it in half, right, because half lives over here and half over here, I'll get this area. So that's the difference between 95% and 68%, right? That's going to give us these 2 sections right here, but I only want one of them, so I'm going to divide it by 2. And there we go. 13.5. I mean, I'm doing this as percentages, so you would then turn that back into a percentage. Or you could leave it as decimals to begin with, right? And then you're going to get the 0.135. Now, you'll notice that these are going to 1 decimal place farther, right? So just be aware that if you're using this rule, that you know, you might just be off 1 percentage there. Or I mean, not 1 percentage, but a decimal at the very end. Okay. Find the area under the standard normal curve between these 2 z-scores. So again, we're going to be using our normal CDF. We're going to give our lower bound, which is negative 1.5. We're going to give our upper bound, which is 2.5. And because we're dealing with z-scores, we're going to have a mean of 0 and a standard deviation of 1. So again, don't forget what are these actual things. This is the lower bound. This is the upper bound. This is the mean. This is the standard deviation. So it's always good to make sure that you can kind of picture what they're asking for. Right, so here's the mean. A z of negative 1.5, so that's over here on the left. Z equals negative 1.5. A z of 2.5, so we're going 2.5 standard deviations. So this is the area that we're finding, right? So we go into second vars, which is our distribution menu. We go down to normal CDF. We give them our lower bound of negative 1.5, our upper bound of 2.5, and we leave our mean and standard deviation as 0 and 1. And that's how we're getting 0.9270 if we round to 4 decimals. Again, make sure your answer makes sense. Does it make sense that I'm getting 92, almost 93% of the data? Well, yeah, because I went really far, right? Went really far to the right here, and I went a full standard deviation to the left, so makes sense. Okay, number 16, find the probability of Z occurring in the indicated region. And then for this problem, they give you the table. So we're going to do this both using the table and using the calculator. So, okay, so let's start with just using the calculator. Okay, so again, this is normal CDF. We have our lower bound of negative infinity, so we write that as negative 1 times 10 to the 99th. That's our lower bound. Our upper bound is this z-score of 1.82. Our mean we're leaving as 0, and our standard deviation we're leaving as 1. So -1 times 10 to the 99th. Upper is 1.82. Okay, so we got the answer. Great. Now let's learn how to use the tables. All right, let me pull one of the tables out here. All right, so the first thing that we want to do is we need to find 1.82 on the table. Okay, here's a table here. So I'm just going to scooch this up. All right, so let's talk about how to read these tables. The z-scores are your numbers on the outside. The numbers in the body are the areas to the left. Do not forget, to the left of z, not to the right, but to the left of z. Okay, so we have the first decimal place of the z-scores over here and the second decimal place of the z-scores over here. So in this problem, we're looking for a z-score of 1.82. Okay, so we're going to find 1.8, which is right there. Okay, let me get my highlighter. So we're looking at this row right here, 1.8. Okay, but it's 1.82. So if I have 1.8 and I add to it 0.02, I get 1.82. Right? Do you guys see that? I think some people sometimes have trouble understanding how this works. That's where we're getting these two separate numbers. We have to look for the 0.02 up top, which is right there. So we're looking at this column. Okay, so to find what the area to the left of this particular z-score is, we find that z-score on the outside, and then we see where they overlap in the body of the chart. So that's how you can get it if you're using the chart rather than your calculator. Okay, so 0.9656, right? We're getting the same number. These values are, they can only do so many decimal places. They go to 4 decimal places. So obviously you might have, some rounding happening. But if you're using the chart, right, if they prompt you for the chart, sure, go ahead and use the chart and you're going to get exactly the number that they're asking for. Whereas if they don't prompt you to use the chart, then maybe just go ahead and use the calculator. Right. Oh, and there was the chart that I could have used. Oh, another thing. So there's two sections of the chart, right? There's the negative z values and the positive z values. Be careful that you are looking at the correct one, right? Negative z values occur to the left of the mean and positive z values to the right of the mean. So just be very careful that you're using the correct one. Okay, so same thing here. Let's go ahead and use the chart for this, find the probability of z occurring in the indicated region. So they're shading to the left of a z-score of negative 0.59. Okay, so on our chart, we're going to look for negative 0.59, negative 0.5, and negative 0.09, right? That's how I get negative 0.59. Okay, so I'm going to move this up here. Negative 0.5 and 0.09. Now, you may have noticed that on the positive side, on the positive chart, it goes sort of 0 to 9, whereas here it goes 9 to 0. So be sure that you're going nice and slow and actually looking at the number that you're looking for and not just saying, oh, it's 9, so I got to go to the end. Well, no, when it's negative and it's a 9 here or 0.09, it's on this side, not on this side. So just take your time, go slow, make sure you're looking at what you're supposed to be looking at, right? So 0.2776. So depending on how quickly you can pull this chart up, might actually be faster than if you were to plug this into the calculator, right? Because remember how we plug this into the calculator? We go to second vars, normal CDF. Our lower bound, we leave it at what's essentially negative infinity. Our upper bound is this negative 0.59. We have a 0 and a 1. And sure enough, we're getting the exact same thing that we got if we did it with the chart. So it's up to you which one you feel you can do faster. I know some people prefer to use the chart when they're prompted for it simply because of the rounding thing, right? Like if you look at this, you have to say, okay, 277, and then that 5 would turn into a 6, right? I mean, not that they have a number that's similar here, but just something to be aware of. Okay. Number 18, find the probability of Z occurring in the indicated region, but this time they have it to the right, okay? So what we're going to do is we're going to find the probability to the left, because remember the chart only gives us the area to the left, and we're just going to subtract it from 1, because remember the area under the whole curve is 1. So if I find this section and subtract it from 1, I'll get this section here. Okay, so again, let's go to the chart. We're looking for a z-score of positive 1.75. So I'm going to go 1.7 and then 0.05. 1.7 and then 0.05. Okay. And again, every step of the way, stop and ask yourself, does this make sense for what I'm trying to find? This is 0.9599. That's a really big number, right? That's almost the entire thing. Well, that makes sense because we just found the area to the left of this. So we do 1 minus that to get the area to the right. And there we go, 0.0401. And if you wanted to do it in the calculator, you would do your normal CDF. You would do your lower bound, well, I shouldn't write that shorter, lower bound of negative infinity, but we can't write that. So negative 1 times 10 to the 99th. Your upper bound. Oh, I'm so sorry. No, we're not. Because we can go directly. Can do directly what it's actually asking for, my lower bound and my upper bound. My lower bound is 1.75. My upper bound is infinity, or 1 times 10 to the 99th. And my mean is 0, and my standard deviation is 1 because I'm dealing with z-scores. I'm trying to find, or I'm giving it a z-score here. So when you're giving it the z-score here, this is 0 and this is 1. So if you're plugging it in this way, you're finding the area to the right because you're telling it what the bounds are, and you don't have to subtract from 1. Right? If we're going to go ahead and plug it into the calculator, we may as well save ourselves the step. Now, that's not to say that you couldn't do it the way that I was starting to do it, where, oh, I'm going to find this area first. So I'm going to do, negative infinity, or 1 times 10 to the 99th, all the way up to an upper bound of 1.75, and I'm going to get that number, and then I'm going to subtract it from 1. Well, if we're plugging it in, we may as well let the calculator do that. So we can do it with what we're actually trying to find. And we get the same thing. All right. Okay, find the probability of Z occurring in the indicated region. So again, we're going to the right. So we're going to do 1 minus whatever we find for a Z corresponding to a Z score of -2. So we go to our chart. We want a Z score of -2.00. Again, this is to the left. Okay, that is not your answer. That is this area right here. 0.0228, which means that the area to the right of it is 1 minus 0.0228. Right? 1 minus 0.0228. And that's how we're getting 97. Okay, so 9759. So let me just double check. 0.0228 negative 2 and 0. Okay, so yeah, I mean, if we were to do sort of rounding here, so let's plug it in, right? Let's say, what if we did normal CDF? I mean, it's still the obvious choice given the options that you have here. But just for kicks, let's do that. All right, our lower bound is negative 2. Our upper bound is 1 times 10 to the 99th, and 0 and 1, 0.9772. Oh, I am so sorry. Here I am thinking, why is that off? Because it's saying to go to 3. All right, so let's do this one again, right? So we're saying between these two, so we're going to do the area to the left of 3, and then we're going to subtract the area to the left of 2. Okay, we already found the area to the left of 2. I'm sorry, negative 2. Apologies. Let's find the area to the left of 3. I knew something wasn't right. It was close enough, but close enough is not what we want to be. 3. So we're going to go on the positive numbers. I'm going to go 3.00. Okay, so we have 0.9987. So the area, so again, to kind of like picture what we're doing here, is we're saying a z-score of 3, and then here's the area to the left of that, everything to the left. And from that, we are going to subtract a z-score of negative 2, everything to the left of that. And that's going to leave us with this section here. Right? So the area to the left with a z-score of 3, that is 0.9987. Okay. Minus, and then the area to the left of a z-score of negative 2, we found it on the table already. That was 0.0228. All right. Much better. 0.9759. Nice and exactly what we're supposed to have as the answer, right? No rounding. All right. Now, again, let's do this in the calculator. Right, so we're going to have normal CDF, second vars. Normal CDF is our second option there. Our lower bound is negative 2, but our upper bound is 3, not infinity, and then 0 and 1. Right, 0.9759 if we were to round to 4 decimal places. So we're still getting the same thing. All right. Okay, great. Let's keep going. All right, find the probability of Z occurring in the indicated region. So for this one, we're going to save ourselves some work because what do we have here? A Z-score of 0. So we know, because remember, what is this actually? What's right in the middle? The mean. So if we go right or left, no standard deviations at all, that's how we get a Z-score of 0. And the mean, the area to the left of the mean is 0.5. The area to the right of the mean is also 0.5. So we don't have to look this up on a chart because we know already that it's 0.5. If you forget that, you look it up on the chart, you find it's 0.5, you go, oh, right, I should have known that. So we're going to do the area to the left of 1.5 minus the area to the left of 0. Z-score of 1.5 and a z-score of 0. Okay, so let's get table out here. Z-score to the left of 1.5 So 1.50. Okay, so sorry, you can't see that. 0.9332. That is the area. Again, what's the numbers inside the body of this are the areas to the left. The numbers on the outside are the z-scores. Okay, so 0.9332. And then we already knew that that was 0.5. So we can just plug that into the calculator to get the 0.4332. If we wanted to plug it in this way, our lower bound is 0. Our upper bound is 1.5. And again, if we're rounding to 4 decimals, we're still getting the same answer. I would suggest doing it both ways, just so that you make sure you understand how to read the chart, how the chart works, but do whichever one is faster. All right, so it is already 11. I don't want to stop yet because we have several other types of problems that we still need to go over. So I might just kind of speed through this one. So I'm just going to go ahead and do this one in the calculator. So our lower bound is 1.36. Our upper bound is, infinity, or 1 times 10 to the 99th. We are looking for a z-score. So that is how we're getting that number right there. When I said we're looking for a z-score, I mean we're using mean of 0, standard deviation of 1. Okay, same thing here. These are z-scores. Again, we can do the chart, find the area to the left, and then from that subtract the area to the left of this minus the area there. Normal CDF, lower bound negative 1.3, upper bound positive 1.2. That's how we're getting 0.7881. Okay, percentiles. So let's remind ourselves, what does that mean? What is the 90th percentile? The 90th percentile means the value that separates the bottom 90 from the top 10. Right? You can put it like that if you want. So 90th percentile means 90% is to the left. Okay, not to the right, but to the left. Okay, so they're wanting us to find the z-score. So instead of finding the area, we're finding the z-score. Okay, so let's pull up the chart. Now, first of all, which chart should we be using? The one that has negative z-scores or the one that has positive z-scores? If the mean is here, anything to the right of the mean is going to have a positive z-score. Anything to the left of the mean is going to have a negative z-score. So we need to pull out the one that has a positive z-score. And what we're going to do is we're going to look for the number in the body that is closest to 0.9000. Because remember, what's in here is the area to the left of the corresponding z-score. So we're going to find the number in here, and then we're going to find its corresponding z-score. All right, so we're going to look around for 0.9. So that is, so we have got two numbers here that are really close. Okay, we've got 0.8997 and 0.9015. So we have to say, okay, well, which of these is closest? If you ignore the decimals for a minute and you say, well, what if this was 9,000? What's closer to 9,000? 8,997, well, that's 3 away, or 9,015, well, that's 15 away. So this one's closer. So you have to choose the one that's closer, and then you're going to look to its corresponding value here and here. So I have a 1.2 and I have a 0.08. So that gives me a 1.28. You do not have to write this down every time, right? 1.28. You can just read it like that. Okay. But that's how we're getting the 1.28. Okay. So remember, inside is the area to the left under the curve. Outside is your z-score. Okay. Oh. had actually printed some of these. Okay, use a standard normal table to find the z-score that corresponds to the 5th percentile. Okay, so again, what does 5th percentile means? It means that only 5% is to the left and the other 95% are over here. Not that you have to label this, but just so that, you make sure that you understand what we're looking at. So if I'm looking at something way over here, I know that I need to be looking at the negative side, right? So I have 0.05, I'm going to find that here. And so that's going to be, we've got 0.0495 and 0.0505. Now, if we use the reasoning that we used on the last one and say, well, which of these is closer to 500, 495 or 505? They are exactly as far away as each other to the 0.05. So what do? We use the value in between them, right? So we're going to go to the left here, and then we're going to go in between. All right, so we're going to go an extra decimal point. So we have negative 1.6, okay, and then we have a 0.05 and a 0.04. So we have, that's how we're getting that extra 4, 5, right? Because between 4 and 5 is 4 and then another 0.5, so 0.045. Right? 0.045. That's what I'm trying to say, is that there's a 0.045 in the middle, right? Because that's halfway between 0.04 and 0.05, right? That's how we're getting that number. Okay. All right. Number 25. Okay. Body temperatures of adults are normally distributed with a mean of 98.6. Let's go ahead and label some of these, right? Mean, 98.6. Standard deviation equals 0.72. What temperature represents the 95th percentile? Okay, so this is where, oops, we are going to be using not just z-scores, right? They're giving us actual actual numbers. Let me draw this out here. Let's do that over here. Okay, so the 95th percentile. So we're going to start kind of the same way that we were doing before. Okay, that means 0.95 is over here, 0.05 is here. Okay, so we're going to do this two ways. We're going to look it up in the chart, and then we're also going to plug it into the calculator. So they want us to find what temperature. Okay, so that's an x value. Okay? The temperature is the x value, not a z-score. But in order to find that x value, we first have to find the corresponding z-score. Once we find the z-score, we're going to use a formula to get us from the z-score to the x value. But we have to first find the z-score. So again, we use our chart. We're going to pull a positive number here. We're looking for 0.95. So that's going to be directly in between these two, right? Directly, halfway in between these two. So we go here and we go directly in between them here. So we are getting z equals 1.645. Okay. All right, that's my z-score. Well, I want to know what the corresponding x value is. Okay, so what are we going to do? We're going to use our formula. The formula says that x is the mean plus z times the standard deviation, right? The mean plus how many ever standard deviations, to the right or to the left. Okay, so let's plug them in. The mean is 98.6. The z-score we just found out was 1.645, and we're going to multiply that by the standard deviation which is 0.72. 98.6 plus 1.645 times 0.72. I didn't really need to have the parentheses there. That's okay. So that's how we're getting a temperature or an X value of 99.78. Okay, so that's important to know how to do that, right? Because you're always wanting to make sure that you understand the relationship between these things and what they actually mean, right? We don't just want to memorize formulas or memorize tools in the calculator. We want to understand why we're doing what we're doing. But if we do want to use the calculator shortcut, right, which we are going to want to know how to do it, what we're going to do is we are using the inverse norm, right? That's the tool that we're using. We're going to go to second vars, okay? And the third option down is inverse norm, right? So if you, excuse me, if you are trying to find the X value given an area, you're kind of working, you can think of it sort of as working backwards, right? Doing the inverse, working backwards, inverse norm. Okay, so the area to the left, right? You're putting in the area to the left. That is 0.95. The mean is 98.6, and the standard deviation is 0.72. Now, again, if you have a calculator where it's not prompting you to say, what am I supposed to be plugging in here? Then you need to make sure that you are putting these in the correct order. So what goes first is the area to the left, and then a comma, and then your mean. These pencils are cute, but they're going to be the death of me. Okay. And then your mean, and then your standard deviation, right? So the area to the left, the mean, the standard deviation. And sure enough, I get the exact same X value. Okay. So again, if we are given the area under the curve and we're trying to find the corresponding X value, or in this case, temperature, right? Or whatever the particular problem is calling for, the X value, as opposed to the Z value, we're using inverse norm. That's when you use that tool, right? Half of stats is knowing when to use what tools, right? Okay, use the standard normal table or technology to find the Z-score that corresponds to the cumulative area, excuse me, 0.2247. Okay, so an area of 0.2247, 22%, that's going to be over here somewhere, right? 0.2247, and then this would be whatever one minus that is, okay? So again, we could use a chart, right? We could look up this in the body of the chart and find its corresponding Z value, Z score. Or what we could do is we could use the inverse norm, right? The tool we just used. And because we're finding a Z score rather than an X value, we just need to make sure that our mean and standard deviation are 0 and 1. Okay, so let's do that in the calculator here. So we're going to go inverse norm. We're going to say the area to the left of the value that we're looking for is 0.2247. The mean is 0 and the standard deviation is 1. When you're trying to find a Z-score, you have to use a mean of 0 and a standard deviation of 1 to find that. Okay, mean of 0, standard deviation of 1. Okay, and that's how we're getting this negative 0.76 if we round to 2 decimals. Okay. Okay. Again, cumulative area of, okay, well this is much bigger. This is 75%, right? So we're going to be way over here. 0.7507. Okay. So again, we're going to do inverse norm, 0.7507. Because we are looking for a Z-score, we are going to leave our mean and standard deviation as 0 and 1. That's how we're getting the 0.68. Again, we could look up this area, this 0.7507 in the body of the chart and look out to the side and the top to find the corresponding z-score if we were to use a chart. Okay, use the standard normal table. So they're specifically asking us to use the table to find the z-score that corresponds to the given percentile. Okay, so which percentile is this? The 90th percentile. Oh, if the area is not in the table, use the entry closest to the area. And yeah, they're just reminding you here, if the area is halfway between them, use the z-score halfway between them. We've already done a few like that. Okay, the 90th percentile. That's supposed to look, it's not supposed to look skewed. I am not an artist. Okay, so the 90th percentile, remember, is 0.9 on that side, which means the other 10 is over here. Not that I have to label that, but just as a reminder. So they want us to use the chart. We're going to find the area under the curve in the body of the chart. Used up all my positive ones. Here we go. So we are looking for, so first of all, I knew to do positive because this is to the right of the mean, not to the left of the mean. All right, so I'm looking for in the body an area, right? The area to the left is 0.9000. So I'm looking for where that is on the table. Okay, so let's see. Okay, so we have, again, these are, funnily enough, same numbers we were using this rule on last time. This is 3 away from 9,000. This is 15 away from 9,000. So this is going to be the one that we want to use because it's closest to 0.9000. So what is the corresponding z-score for this? 1.28, right? 1.28. Okay. Find the indicated z-score shown in the graph to the right. So again, they're giving us an area and they're asking for the corresponding z-score. It might be faster to use the chart or it might be faster to use your calculator. We're going to do inverse norm. The area to the left is 0.1469. Because we're looking for a z-score, we're going to leave our mean as 0 and our standard deviation as 1. And that's how we're getting negative 1.05 if we go to 2 decimal places. All right, find the indicated z-score in the graph on the right. Okay, so this one is a little bit different because they're giving us the area on the right. Well, the graph, the charts don't give us the area on the right, they give us the area on the left. So if we were to look this up on the chart, we would have to start by saying 1 minus 0.0951 to tell us that the area over here is 0.9049, and that is the area that we look up in the chart, is 0.9049. Or we do inverse norm. The area is 0.9049 because we always have to give it the area to the left. We're looking for a z-score. We leave our mean as 1 and our standard deviation. I'm sorry, our mean is 0 and our standard deviation is 1. And that's how we're getting 1.31 as rounded to 2 decimals. Okay, so the lengths of lumber a machine cuts are normally distributed with a mean of 104 inches. I'll label some stuff here. Mean of 104 inches and a standard deviation of 0.3 inch. All right, what is the probability that a randomly selected board cut by the machine has a length greater than 104.09 inches? All right, so for this one, we have, move this over here. Okay, so we have we have our mean of 104 and it's, well, let me switch pencils here. it's asking about 104.09. So that's somewhere to the right. Don't know exactly how far to the right, but that is an X value of 104.09 inches. What is the probability that a randomly selected board cut by the machine has a length greater than 104.09 inches? Okay, so we are trying to find the probability that it is over here on the right, not on the left. Okay, we're going to be using normal CDF, right? Going to go down to normal CDF. We're going to give it the lower bound, which is 104.09. The upper bound is all the way over here to infinity, or 1 times 10 to the 99th. Because we're giving it an X value, we need to give it the actual mean and the actual standard deviation, right? The mean is 104, the standard deviation is 0.3. Okay, that's how we're getting the 0.38 to 1 if we rounded to 4 decimal places. Okay, normal CDF. Lower bound 104.09, upper bound 1 times 10 to the 99th, mean of 104, standard deviation of 0.3. Right, that's what we plugged in. Okay, so that was A. But B is a little bit different. So B says a sample of 45 boards is randomly selected. What's the probability that their mean length is greater than 104.09? So we're not looking at all of them. We're only looking at a sample of 45 of them. Okay, so this is where we have to use some of those other formulas that we've learned, okay? We're going to start by finding the standard error of the mean, right? So our standard error of the mean, that's our standard deviation over the square root of n. Okay, once we find that, we're going to use that value to find the corresponding z-score here, okay, so that we can then find the area to the right of it. Okay, so the formula for that is the value minus the mean over the standard error, right? The value minus the mean over the standard error, right? So that's what this is. So we're going to find that because that's what's going to get plugged into there. Okay, so we have to find this before we can plug it into there. Okay, so that's going to be the standard deviation we said was 0.3, okay? And the n is this 45, right? The number that we have randomly selected from the whole thing. So that's what goes over the square root of 45. So we're going to do 0.3 divided by the square root of 45. Okay, so we're getting approximately 0.0447. Okay, we're going to plug that in to this formula now, right? So now we're finding the z-score. Okay, so we have z equals, okay, so this x value, that is what they're asking for, right? That is what we're trying to find the area to the right of, this 104.09, okay, minus the mean, which is the 104, all over this number that we just found, right? 0.0447. So just because I don't want to round, I'm going to plug this in so that I don't have to retype that number. So I'm going to go 104.09 minus 104 divided by second answer. Okay. So let's see. Did I plug something in wrong here? 104.09 minus 104. No, we're good. Okay, so remember what we just found? This is the X value here was 104.09. Its corresponding Z-score is 2.012461118, blah, blah, blah. Okay, so what we're going to do is we are going to go into normal CDF to say, what is the area to the right of that? Okay, so our lower bound is our Z-score of 2.012. Our upper is infinity. So because this is a Z-score, we have to use a 0 and a 1. Okay, so remember, you can't just plug it in like that when you are talking, or I'm sorry, you can't plug in the X value as opposed to the Z value, and use your mean and standard deviation, because this mean and this standard deviation is for all of the lumber. We're not talking about all of the lumber, we're talking about just 45 of them. So we have this little bit of error here, right? That's why this standard deviation is slightly different, right? This number is not the same as this number. The standard deviation, or the deviation of this sample of 45, of all the boards, we're only using 45. So our standard deviation is slightly different than the population standard deviation. It's kind of how you can think of it. Okay, so that's how we're getting that number. Okay, and then, yeah, so that's 31. All right. And last one, I know we're over on time, but this is the last one. All right, so 32, the weights of ice cream cartons are normally distributed with a mean weight of 9 ounces and a standard deviation of 0.3. What is the probability that a randomly selected carton has a weight greater than 9.11 ounces? So let's go ahead and do that in the calculator. So if we wanted to draw a picture of what's happening here, we have, so our mean is 9. So we're going to be to the right of that with an X value of 9.11. And they want the probability that it is greater than that. So we're finding the area to the right of that. Okay. So they haven't asked us to do just a small sample of those yet. So we're allowed to use the normal CDF to say that our lower bound is 9.11, our upper bound is infinity, and adjust our mean and our standard deviation accordingly. Okay, that's how we're getting the 0.3569. But with part B, similar to the other one we did, we need to go ahead and find our standard error first, which again is the standard deviation over the square root of n. So sample of 36 cartons, that's our n. So we have 0.3 over the square root of 36. 0.3 over square root of 36 is 6, so we get 0.05. So this is the standard error for this sample. So that's why we have to calculate this, because this is what we're using. Okay, then we can plug that into our formula to find the z-score. Okay, so again, this is our specific value that we're looking at, right? 9.11 minus the mean 9 over the standard error, which we just calculated to be 0.05. So 9.11 minus 9 over 0.05. So we get 2.2. So that's our corresponding z-score to that value is 2.2. Okay, and now we can find the area to the right of that z-score. Okay, so we go through this extra step when we're doing a sample, because we have of a smaller amount, excuse me, because then we're going to have that standard variance. Okay, so second VARS, normal CDF, our lower limit, we're doing the z-score of 2.2, upper of infinity. Our mean is 0. Our standard deviation is 1. We're using the z-scores. That's how we get 0.0139. Okay, so that's the whole thing. That's all the questions I have here. Again, I'm going to put this up so that you guys can watch it when you have time. Don't hesitate to reach out to your instructor if you have questions. Don't hesitate to go into any of the academic support centers. We have ASCs on every single campus, except for the ATC. You can find the hours for the Academic Support Center on our homepage. I'll include that information in the email that I send out. We also have online chat available in the evenings until 7:30. Monday through Thursday, and then until 5 on Fridays. So if you can't physically come in, you can use the virtual chat and get help. And then on Saturdays, we have one location that is open on Saturdays from 8 to 4. That is the Daytona Beach campus, building 115. I know this says New Smyrna Beach, but I'm at a different campus each day practically. So you can find that information on the ASC's homepage. Don't hesitate to, like I said, reach out to your instructor if you have questions, reach out to me if you have questions, reach out to any of the staff at any of the ASCs if you have any questions. I hope this was helpful, and good luck on your exam.